And welcome back. We're getting more of Swiss Re now, this time with Jürg Schelldorfer, talking about neural networks and random forests in insurance risk modeling. Jürg is a senior data scientist in the digital and smart analytics team of Swiss Re, and he will give us an overview of the most important aspects for the appropriate use of neural networks and random forests for the application of these machine learning techniques in the insurance sector. Have fun with Jürg. Thank you.
Thank you very much, Corinne, for this kind introduction. So I'd like to start, as probably not all of you are very familiar with insurance or insurance risk modeling. First of all, I'd like to spend some time on explaining some insurance-specific things. So first of all, let's start with what is insurance or insurance risk modeling. And I think you see a picture here on this slide. I said it explains in a very short way what is insurance about. So insurance, first of all, you buy a protection against financial losses. And at the core of insurance, there is an exchange of certainty against uncertainty. So you, as a policy holder, you don't know if you will have a car accident within the next 12 months. So we have an uncertainty about that. And insurance is that you transfer the uncertainty or the cost of this uncertainty to the insurance company. And the only thing you do is you need to pay a fixed premium for that. So therefore you transfer the uncertainty to the insurance company. And in case there is a claim, that the insurance company compensates you for the losses you have had. And therefore you see that the insurance company needs to deal with this uncertainty. Now, later on, I will focus very, very much on insurance pricing. And insurance pricing is about determining this fixed amount that you need to pay to give the uncertainty to the insurance company. Now, when we talk about using machine learning in insurance, we try to write down why this might be not just solving a standard machine learning problem. So let me start with the first dimension. In textbook machine learning, it's very much about point prediction. But insurance, as I said, is about uncertainty. So you need to understand the whole distribution. And this has to do with the fact that for every insurance contract you write, you need to have capital to put aside. And this depends on the distribution. So it's often called probabilistic forecast. Secondly, when we look at the type of distribution we have in insurance, they are skewed, asymmetric, and also with many experience of insurance, you never see something which is Gaussian. And in machine learning, you often have a symmetric or Gaussian type of distribution. And if you look for a machine learning optimal model, then there are many more dimensions you need to consider than just prediction performance. For example, it's very important to have stability over time, to have explainability, and also that the model aligns with regulatory requirement. So maybe you see a bit more on the slides, and I'm very welcome any questions and comments on that. So after this introduction, I'm going to talk about 4 things that are new and I think important. So which means if you are an insurance mathematician and applying machine learning in insurance, you should know about. And also for data scientists who are dealing with insurance risk type of data, I think these are 4 things that you should keep in mind because they are very specific to insurance risk modeling. So now let's think of insurance pricing, so determining the fixed premium. So let's assume that, okay, we want to use a neural network for that. And in insurance pricing, you often have categorical variables, many of them with a lot of different levels. Just think if you offer a car insurance, you have a model for a car which opens you a universe of hundreds of different cars. And in the standard or traditional pricing, you use a GLM. And how you deal with categorical variable? Of course, you use one-hot encoding. Now, when you use one-hot encoding with a neural network, I don't recommend to do that, because if you look at a very simple neural network you see on the slides, you get an enormous amount of parameters you want to estimate. And this is usually a problem when you think of stability and the algorithmic performance of your algorithm. And therefore, in machine learning, there's a very good technique which is called feature embedding, which helps you a lot, first of all, to reduce the parameter of your neural network, which is really something that is important and appreciated in insurance risk modeling. And secondly, an advantage you get is that with this embedding, you get a visualization of your levels of the categorical features in a 1, 2, or 3-dimensional space. And this is very advantageous to communicate the pricing model to a wide range of stakeholders. What I have to say, if you use feature embeddings, that you cannot expect that the prediction performance is really better compared with just using a one-hot encoding. Then the second topic I'd like to talk about is something that has been recently proposed, which is called combined actuarial neural network. So let me motivate that where it's coming from. So in insurance pricing, you don't start with a model from scratch, because over the last years, you have usually already a productive pricing model in production. And therefore, we got the feedback that for insurance mathematicians, you're a bit hesitant in just starting and introducing a neural network from scratch. And it's very important that you can compare the current model in deployment to a potential new model you are going to deploy. And therefore, there is a very nice way how to deal with that, and this is very well known in the machine learning community, and this is called a skip connection. So we were looking into the skip connection and found out, well, that's a very nice way of embedding the current GLM and pricing model you have into a neural network. And then what you do is, with that approach, you are looking and investigating how good your GLM is, and you can identify areas or areas where you can improve your current existing GLM. So it's really about the neural networks helps you in a very natural way into identifying where you can improve your current GLM. And that's one benefit you have, because you can still base everything you do on the GLM you already have. And there's a second thing that is very important. At the beginning I said, in insurance, it's a lot about the uncertainty and uncertainty quantification. And with this model, there's a very natural and easy way to determine the uncertainty. Because what you typically do when you don't know how to quantify uncertainty, you run a bootstrap type approach, you rerun your model, and we have found that if we do that with a neural network, it needs a lot of time. And with this newly suggested approach, there's a very good way of assessing the uncertainty in an improved pricing model combining GLMs and neural networks. The next point I'd like to talk about is, we call it portfolio bias in neural network. So now let's again start from the beginning. You want to develop a new pricing model and you want to use a neural network. And now let's do an exercise in the mind. What is the problem with this portfolio bias? So if you think of a pool of policyholders which is fixed, and if everyone needs to pay the same price, that's very simple to determine, okay? Everyone pays the same price, and overall, what you earn as an insurance company as premium is exactly what you want to get. The price, with the price, you need to cover your expected losses in the future. And now when we think of maybe that's not the right thing, it does not differentiate, and therefore you start with a GLM. So the GLM helps you to differentiate the price for the individual policyholders. And if you still get the whole premium from all your policyholders, you still get exactly the right premium that you need to have. And now let's do the last step, is that we say, okay, let's use a neural network which enables a better price differentiation and which gives you different price estimates for the individual policyholder. And let's assume the policyholder paid that price. There's an empirical and theoretical issue that you will see is that you get the wrong price, premium overall. So which means that using just a neural network, you get the wrong premium, so which might be too high or too low to cover your insurance losses. And in insurance, there's rarely a CEO or a senior management which signs off and says, yes, we are charging a price, we know it's wrong. No, it's not working like that. So therefore, you need to be aware of this bias and you need to think how to correct that. And therefore, there's one way how to correct for that is that you run your neural network. And in the last layer, when you think of a feed-forward neural network, you take this output of the last layer, you put that as the features for your GLM, you run a GLM, and again, you get to a price level which overall is exactly what you want to have. And another question is, well, why is this happening? And it was not easy to find out. The reason is that it has to do with the Erlings-Topic criteria. So the Erlings-Topic criteria is there to prevent overfitting for neural network, and therefore, mathematically, you have these biases. Then the last point I'd like to talk about is the use of random forest in insurance. So random forest is a very well-known machine learning technique and shows very good predictive performance. Now, let's look at three visualization how distributions like in insurance. So on the left of the graph, you see the number of claims that individual policyholder have. So you see that's very skewed with a lot of zeros at the very left. Then when we visualize the claim amount that this policyholder generate, we also see that's quite a skewed distribution. So I think it's very clear from this view that has nothing to do with Gaussian distributions. I think without saying so much more about that. And now if you say, well, I want to use a random forest for insurance data like that, and maybe you think of using a Python or an R library, you will see or maybe not see that random forest by default is based on the assumption of Gaussian data. So therefore, when you just run a random forest in one of these languages, you will optimize your algorithm with respect to Gaussian distribution. And if you look at the graph, at the pictures above, I'm not sure if you're really getting out the right thing. And therefore, we really recommend that if you use a random forest for insurance data, to consider what is the underlying distribution and to use very specific packages which are partly available, partly not, such that the performance of your model is really in line with the underlying distributions. So with that, I'd like to come to the conclusion. So using random forest and neural networks can help in improving insurance risk models. And we have highlighted 4 points, which is first about using embedding for categorical features. Then you need to correct for a potential bias in neural network. Then you can use the combined actuarial neural network. And when you use random forest, make sure you're using the appropriate distribution. And yet, as a concluding remark, we still say that if you have a very well-trained and evolved and sophisticated GLM, a neural network might not be better than a very good trained GLM.
Okay, Jürg, thank you very much for giving us these insights. Move it a bit closer so that we're both in the picture. One question I have to ask you. You're talking about the GLMs, the classical insurance models. Do you think they will last? We are in the age of individualization. People are talking about usage-based pricing, user-based pricing, individual pricing. So what about the neural networks and the random forests if new insurance models, pricing models appear?
I think in the next few years, I expect that there will be GLMs, neural network, maybe GLMs which have been trained or with neural network, but at the end still put them into a GLM. GLMs still have many advantages, and they often fit very well in the infrastructure that insurance companies have. Of course, there's now a move to enable more machine learning model, but I expect over the next few years, GLM will still be there.
So your efforts won't be in vain, but put into use very well.
Exactly, that's what I expect. Yeah.
Okay, Jürg, thank you very much for your time and your insights, and have a great day.
Thank you very much.